Welcome to the Explainer. Today, we're going to build the mental framework that every new developer needs to really understand the big picture of software. We're going to move beyond just the code you write every day to see the entire system that holds it all together. So, have you ever cloned a professional project, opened it up, and just felt completely and totally overwhelmed by all the files and folders? Yeah, you're not alone. That feeling right there is actually the first sign that you're starting to see beyond the individual lines of code and you're ready to understand that bigger picture. Look, you've probably spent years getting really good at looking at the trees. You know, the functions, the loops, the algorithms. This explainer is all about learning to see the forest, the software architecture that gives the whole system its shape and its structure. Okay, so here's our game plan. First, we'll go beyond the code to see why we even need a plan in the first place. Then we'll learn the language of the blueprint itself. After that, we're going to explore 3 really common architectural styles, see how to actually draw the plans, and finally figure out exactly where you fit in on the crew. So why can't a team of really brilliant developers just, start coding and figure it all out as they go? Well, let's use an analogy here to understand why that's not such a great idea. Writing a small script is a lot like building a doghouse. You can kind of just grab some wood and nails and start hammering away. If you make a mistake, no big deal, it's easy to fix. But enterprise software, that's a skyscraper. You would never, ever start pouring concrete for a skyscraper without incredibly detailed blueprints. The cost of a mistake is just disastrously high. And this quote, man, it just gets to the absolute heart of it. Architecture isn't about the small stuff, like which kind of loop you use. No, it's about the big, foundational decisions, like your database choice or the entire system structure that are incredibly difficult and super expensive to change once the project is built. Okay, so if you're going to read those blueprints, you need to understand the language, right? You need to know the symbols. So let's build up our vocabulary with a couple of core concepts. At the very heart of all this are 2 things: components and interfaces. Just think of components like individual Lego bricks, a user service, a payment processor. The interfaces, well, those are the little studs on top of the bricks. They define exactly how the bricks can connect, and you don't need to know anything about what's going on inside the plastic. Now, here's something interesting. A lot of the time, architecture is less about what a system does and more about how it does it. These are called the quality attributes, or as people in the know call them, the abilities. Things like scalability, maintainability, security. These are the things that really shape the design. And this right here perfectly illustrates the architect's main challenge. You can't have everything. It's a constant game of trade-offs. If you want lightning-fast performance by keeping all your data in memory, you're giving up reliability if the power goes out. Every single architectural choice is about balancing these competing needs. Architects don't just reinvent the wheel for every single project. They have a toolbox full of standard patterns or styles. So let's take a look at 3 of the most common ones you're going to see out there in the wild. First up is the layered architecture. Sometimes you'll hear it called N-tier. This is really the classic starting point for a ton of applications. The main idea here is to separate your code into these horizontal layers where each layer has a very, very specific job. So here's how it works. A request starts at the top in what we call the presentation layer, or the UI. From there, it flows down through the business logic layer, which is where all the rules are enforced. And then it goes to the data access layer, which is the only part that knows how to talk to the database. And the golden rule here is simple. A layer only talks to the one directly below it. It's clean, it's simple, and it's pretty easy to understand. Next up is the pattern that powers the absolute giants of the internet, microservices. Instead of building one giant, massive application, what we call a monolith, you break it down into dozens of tiny, independent applications that each handle one specific business function. Just think about Netflix. There isn't one big Netflix program running somewhere. Nope. There's a user service, a catalog service, a recommendation service, and on and on. And each one has its own database and can be updated and deployed all by itself. This gives you incredible scale and flexibility, but it also introduces a ton of complexity in making sure all these parts talk to each other correctly. All right, our third pattern kind of flips the whole communication model on its head. In an event-driven architecture, services are totally decoupled. They don't call each other directly. Think of a busy kitchen. Instead of a waiter yelling an order at a specific chef, they just put the ticket on that central wheel for any available chef to grab. Services basically publish that something happened, and other services can subscribe and react to it.
So check this out. When an order is placed, Service A doesn't tell the shipping service and the notification service what to do. Nope. It just publishes an order placed event to a central event bus. Then, the shipping service and the notification service, who are both subscribed to that event, pick it up and do their work, all without Service A even knowing they exist. This creates a really scalable and resilient system.
Okay, this is super important. An architecture that only exists in someone's head is completely and totally useless. You have to be able to communicate it clearly. A simple but really powerful framework for this is something called the C4 model. The C4 model basically gives you 4 different zoom levels for your diagrams, like Google Maps for your code. You start at the highest level, the context view, which shows your system as just one box interacting with users. This is perfect for talking to business folks. Then you zoom in to containers, showing the major pieces like the web app, the API, the database. Zoom in again to components to see how a single container is built. It just makes sure you have the right map for the right conversation. Okay, so I know what you might be thinking. This all sounds very high-level, very senior dev stuff, right? But the truth is, you're already interacting with and influencing your team's architecture every single day. So let's talk about how you can start contributing right now. Your role here, it really starts with curiosity. Start asking senior engineers why the system is built a certain way. Respect the patterns that are already there. They usually exist for a very good reason. And maybe most importantly, own the quality of your code. Great systems are built from great components, and you are building those components every single day. Understanding these concepts is a fundamental shift in perspective. It's about moving from just writing code to really understanding how your code fits into the larger machine. And I promise you, this knowledge is what will accelerate your journey from being a coder to being a true engineer. So we'll leave you with that challenge. The next time you work on a ticket, don't just finish the task. Take a moment to ask yourself, how does this fit into the bigger picture? Thanks for joining us for this explainer.